It's the planet's most vital organ, breathing in excess heat and exhaling oxygen. The ocean, also home to much coveted resources.
More and more industrial companies see it as a new El Dorado.
Pollution, rising temperatures, and overfishing. The seas are getting sicker.
The ocean plays a big role in climate regulation, and it is under threat. When findings are clear-cut, you have to act.
France's scientists are hunting for solutions at a time of great global uncertainty.
What the Trump administration wants to do is negotiate with science. And if they can't cut a deal, they break things, they fire people.
At the far tip of Brittany's coastline, a team of engineers is trying out a new prototype. 6 months of tests before a journey to the deep seas.
It's great to see it function after 4 years of work.
It's an achievement, you know. What you can see here are floats that are part of the Argo network.
They're going to dive down 6,000 meters. Previous models only reached 2,000 or 4,000.
Nicknamed the ocean's thermometers, the high-tech cylinders are part of a more than 4,000-strong international network dotted across the oceans. They dive several kilometers down and slowly make their way back up to the surface to send back data on the salinity, pressure, and above all, temperature of the water. A cycle on repeat for up to 7 years.
You have the same sort of constraints as when you send a satellite into space for long-distance exploration. There are real technological challenges going to 6,000 meters, because at this distance, it's completely dark and extremely cold. And above all, there is massive pressure from the water above, measuring more than 600 bars.
6,000 meters, a first for France. A way to see how even the deepest parts of the oceans are warming up.
Argo is an example of unique international cooperation for science, for the planet. It was a quiet revolution for ocean sciences. It allows us to monitor the climate and its changes. Today, we know that roughly 90% of heat emitted by mankind from human activities is stored in the ocean.
There could be troubled waters ahead, though, as half the floats currently in use belong to the US. Climate change projects are in the crosshairs of Donald Trump.
We are withdrawing from the Paris Climate Treaty.
Crippling cuts and mass firings. While some projects are business as usual, French researchers have sometimes seen ties cut with American counterparts.
The Trump administration has made lots of different decisions, including some that are linked to climate change denial, to put it simply. It makes us wonder if the US will continue to invest in these floats, which reach 6,000 meters, or if they will withdraw from the project altogether. These are the sorts of questions we're asking.
France's Ocean Research Centre IFREMER has worked with the US for decades, including on the joint discovery of the Titanic shipwreck in 1985. In 2024, 20% of the organization's publications were written with American counterparts. A vital source of knowledge and financial backing.
If Americans pull out of projects, that means a loss of funding. What the Trump administration wants to do is negotiate with science, negotiate with biodiversity, with the climate. But you can't negotiate with science.
Fabrice Pernet has spent almost 10 years analyzing one of the direct consequences of excess carbon dioxide in the atmosphere.
Right here, we may have a way to fight back against the acidification of the oceans. Seaweed is a potential remedy to this problem. An ocean with acidic water is a sick ocean, and it loses its wealth of resources, all the diverse species it shelters.
The ocean is becoming increasingly acidic and corrosive for seashells as it absorbs more CO2. Inside this laboratory, an experiment is underway.
Here we have aquariums with oysters on their own in acidic water, in conditions predicted for the year 2100. And over here, oysters in regular seawater. At the beginning, the shell mass was the same. And here you can see this is roughly half the size.
Fabrice is growing seaweed alongside oysters to see if they can lower the water acidity.
The seaweed here, thanks to the lights above it, will capture the excess CO2 in the water to grow, and thereby lower the acidity of the water. This means they will grow better. The shells won't be eroded away by the water acidity.
The experiment is ongoing, so too soon to draw conclusions. Fabrice is optimistic, though.
Oysters with seaweed seem to be doing better. They grow better with better formed shells. They have a better color.
France is the world's largest oyster exporter, but the shellfish isn't just a tasty dish. It also plays a vital role in the oceans.
Shellfish are filters, and without them, water goes murky, brown. Light can no longer penetrate, and in the end, everything dies. The oyster is, in a way, an indicator of how healthy the water is.
Research stretches far beyond laboratory walls, and increasingly with the help of the general public and ocean enthusiasts. Like here, in Cancale, with the Al-Larc Association.
Sortie de l'association Al-Larc sur un protocole de suivi mammifères marins.
Je vous remercie pour les informations. Je vous souhaite une bonne sortie.
In the Gulf of St. Malo, there is a sedentary population of large dolphins, around 500 to 600 of them. That makes it the largest population in Europe. That's why we are lucky enough to regularly come across them.
Gaël Gauthier has been monitoring the Mont Saint-Michel Bay for almost 2 decades, with a team of volunteers.
Les requins, peu probable. Tortue marine, peu probable. Tu n'as plus que ce qui t'intéresse sur le côté. On gagne un temps fou.
Carefully logging each marine mammal sighting, collecting data to be analysed later on, all alongside his scientific coordinator.
We monitor in several different ways, notably with photo identification. So we take photos of the dorsal fin and then use them to estimate the size of the population. We created a participatory science program where we train up volunteers so they can sort through the photos.
No dolphins today, but the association has had many opportunities to capture them on camera. All the information is uploaded to an app and shared with other marine mammal specialists, frontline witnesses to any change in the ecosystem.
Over the years, the rising water temperature will have a massive impact on the sustainability and equilibrium of the marine ecosystem. So there needs to be monitoring. There needs to be rigorous scientific work. You can't do it any old way. It isn't an opinion. There are facts. This is also why the work of small structures all along the French coast is interesting. All these structures will, in their own way, contribute to the bigger picture.
Ifremer increasingly uses organisations like these as a precious source for fieldwork.
When it comes to marine research, there are lots of things that can be done with participatory science. For example, colleagues teamed up with the association Surfrider. The surfers were concerned about the presence of chemical contaminants in the water. So we equipped some of their wetsuits with sensors that can measure the presence of these contaminants over time.
As science continues its quest for a greater understanding of the ocean, many secrets remain hidden in its depths. Today, these mineral-rich spheres, dotted 4,000 to 6,000 meters below sea level, are a source of both great interest and concern.
This is a polymetallic nodule. This is what we find in the deep ocean in the area we study in the middle of the Pacific, where they are in abundant supply.
Formed from mineral concretions over millions of years, they contain critical and coveted metals like nickel, cobalt, and copper.
Some elements in these nodules are used in new technologies, electric car batteries, smartphones, solar panels. So industrial companies increasingly see the deep sea like a new El Dorado.
De plus en plus d'industriels considèrent que c'est un peu un nouvel Eldorado.
Pierre-Antoine Descendier's team has just returned from a month-and-a-half-long mission, collecting nodules and analysing their potential, as well as the organisms that live alongside them.
Here we have the samples we collected during the Eden campaign in the Pacific Ocean. In each of these pots, you can imagine there are several hundreds of organisms. There are also a lot of species because it's an environment that is characterized by great diversity. Half of them we don't even know. They're not referenced in science, so that means there are potentially hundreds of species to still discover.
Environmentalists warn that the extraction process could cause severe disruption to the seabed, marine biodiversity, as well as jeopardize the ocean's carbon storage capabilities.
There is, generally speaking, a scientific consensus that we don't have all the data we need. We don't have the bigger picture yet, which justifies a moratorium because it's too soon.
Yet, in April, Donald Trump signed an executive order to fast-track mineral extraction, including in international waters. Some fear other countries could follow suit, kicking off a global deep-sea gold rush.